Okay, dokie. Number 2. So we've done number 1. That was putting the 8 centimeters into perspective with something. We tried to do it with the 1 degree of distance, and it's still kind of up in the air. Number 2. We've got ourselves the Milankovitch, I think it's spelled right, Milankovitch cycles. The Milankovitch cycles is a natural cycle that the planet takes that has been happening since the very beginning. It's because of gravity, the way it got slung out of the sun or wherever it appeared from. We've ended up in this elliptical orbit around the sun. And as we're orbiting, we also tilt on our axis like a spinning top. You spin a top and it goes, but very slightly. It's always, the top's always spinning unless you get the perfect spin. That unperfect spin is called the Milankovitch cycles, right? And it's been worked out by sediment that they found, some ice cores. They could just see that there's been some kind of tilt in the past in the planet, and it all ties in with the ice ages as well. So all of these things, all of these facts could tie in with each other, okay? Love facts. Now, this is where it gets interesting. The planet is currently on a 23.5 degree tilt off of its axis, that way. It's actually 2, 3, 4, 4, but we're rounding down to keep it friendly. All right? So the planet is in a 23.5 degree axis spin. So going around off center. Now in 10,000 years time, we're going to go all the way to our minimum angle of actual rotation, which is 22.1 degrees. That's in 10,000 years. This is the Milankovitch cycles, okay? That is our minimum angle, and then 20 years later, we go from the 221 degrees all the way to our maximum axis tilt as we're orbiting the sun. And that's 24.5 degrees. Now this takes 20,000 years to happen, one way. So then it gets down to the bottom and it goes up again. So it's 40,000 years per cycle. Return ticket, okay? 20,000 years from 22.1 degrees to 24.5 degrees. All right? Now, there's only a couple of things we need to think of here. The amount of time it takes and the difference in the lowest and highest of the tilts. The difference is 24.5 minus 22.1 gives us total degrees difference of 2.4, okay? 2.4 degrees, right? Now, the 80 centimeters over yonder was a 138,750th of 1 degree. The Milankovitch cycle has a maximum and minimum difference of 2.4 degrees, right? 138,750th of a degree. We have ourselves 2.4 whole degrees of natural axis tilt, okay? Natural. Gets better. 2.4 degrees over 20,000 years. What do? We need to start putting everything into something that we want, something we understand. That is centimeters, okay? We want centimeters, or we have to turn that into something else and put it alongside something so we can see the size of it. So we have 2.4 degrees, we're going to go times 1 degree, okay? That's 111 kilometers, right? So what we get is 266 kilometers, right? So 1 degree was 11,100,000 centimeters. When we multiply the 2.4 by the 111, we get 266 kilometers. We turn that into centimeters, exactly like we did over on the other side, by adding 5 zeros, 100,000. 266 kilometers, rounded down, I think it was 266.4, becomes 26,600,000 centimeters, right? This is 2.4 degrees of natural axis tilt because of gravity. Gravity, the moon, Jupiter, the sun, gravity. Now, what do we want to do? We need to get this thing smaller. So what we do, we've got 26,600,000 centimeters and we've got 20,000 years. Perfect. Now we can work out how much actual tilt there is down to the years. Okay? So, we're going to divide 26,600,000 by the 20 years. A couple of ways of doing it. Best way is obviously not the zeros, that's 4 zeros. 1, 2, 3, 4. We've got, ignore the comma, we've got 2,660 divided by 2, 1,330. So the natural axis tilt of this planet is 1,330 centimeters per year. Centimeters, let's bump that up into meters. 1,330 centimeters divided by 100, because there are 100 centimeters in a meter, gives us 13.3 meters per year. 13.3 meters of natural axis tilt is going on every single year. 13.3 meters per year, 80 centimeters over 17 years. Excuse me? If we divide that 13.3 meters by 12, it will give us how much natural axis tilt this planet is going through every month. 13.3 divided by 12 months, that's 1.1 meters every month. This planet is naturally tilting by 1.1 meters every single month. The 80 centimeters of actual tilt that they think is happening because of the amount of water that's been pumped and displaced between the years of 1993 and